Let's determine the volume of f of x is equal to the square root of x rotated about the x-axis. So we have f of x is equal to the square root of x. So let's first draw how this graph looks like, and then we'll actually try to conceptualize it a bit before we actually do the integral. So we have our y-axis and our x-axis, and we know that the square root graph looks something like this. And what we want to do is we want to rotate this about the x-axis and find the volume from 0 to 1. So this is the x domain. So if we rotate this about the x-axis, we get circles that look like this. So we form some sort of three-dimensional shape that looks something like this. And so our goal here is to find the volume of this shape. Volume of this shape. Now, we talked about in the previous video that essentially what we can do is we can take the areas of these thin slices of circles and just add them vertically. And so that's the definition of integral, right? We take infinitesimally small areas and we just add an infinite amount of them to get the volume. So this is the integral from 0 to 1 of the area of a circle is pi r squared, but we have to notice that the radius of these circles changes as a function of x. So as x goes this way, the radius of those circles change. So I'm going to say pi radius as a function of x squared dx. Now we have to figure out what this radius is. Well, seems like the radius is just determined by the height of the function. So if I pick this thin slice right here, I can represent the radius by just the distance from the x-axis to the function. This is the radius, and it keeps changing as the function gets bigger and bigger. So the radius can be denoted as just the square root of x from 0 to 1. So I can rewrite this as the integral from 0 to 1 of pi the square root of x squared dx, which is equal to, again, the integral from 0 to 1 of just pi x dx. And again, we can use an anti-power rule here for this. We can take the constant out and let this be pi integral from 0 to 1 of just x dx. And the integral of x, well, I'm going to move right here. The integral of x is just x squared over 2, right? Because the derivative of x squared over 2 is x. And there's a pi there, we can't forget that, from 0 to 1. So we evaluate this integral at those two values, and we get pi over 2 as the volume of this object.